If you're trying to decide between Snowflake, Databricks, and Microsoft Fabric right now, the most important thing I can tell you is this: there is no universal answer. What I found is that the platforms are closer than the vendors want you to believe. What actually determines the outcome is how well the platform matches your specific constraints, and that's what we're going to break down today. In 2026, the data platform market has effectively consolidated into three serious contenders for mid-market and enterprise organizations: Snowflake, Databricks, and Microsoft Fabric. Each vendor has a compelling story. The analyst reports position them differently, and most organizations are in the middle of evaluating or reevaluating which direction to go. What I want to offer today is a structured perspective. 7 critical dimensions scored 1 to 5, specifically to help our clients make better, clearer decisions. I'll walk you through every dimension, give you the honest assessment of each platform's strengths and limitations, and close with a practical decision framework you can use in your own evaluation. Let's get into it. We evaluated each platform across 7 dimensions. Let me briefly define each one before we go any deeper. So dimension 1 is the cost at scale. How predictable and controllable cost becomes once you cross meaningful workload thresholds. Dimension 2, multi-tenant isolation. How cleanly the platform supports tenant per row, tenant per schema, and tenant per database patterns, including row-level security, resource isolation, and per tenant cost attribution. Third is governance and lineage, catalog maturity, automated lineage, access policy expressiveness, audit trail quality, and how much of governance you have to build yourself. Mission 4 is time to first pipeline. From contract signature to a production pipeline serving real business users, how long does it realistically take? This captures onboarding complexity, documentation quality, and the learning curve for the engineering team. Dimension 5, semantic layer fit. Semantic layer provides a single governed definition for your key business metrics: revenue, customer count, churn. Basically, how easy it is for a reporting or an analytics platform to access and integrate with the semantic layer. Dimension 6, AI ML readiness. How well does the platform natively support feature stores, model serving, and how well does it allow the creation of various AI and machine learning models within its infrastructure? And the final dimension, dimension 7, it's the quality of platform ownership. Do you need a team to maintain and run the platform, or is it simple to maintain? So first, let's talk about Microsoft Fabric. Fabric's primary strength is its integration with the Microsoft ecosystem, specifically Power BI. If your organization already uses Power BI as its primary reporting tool, Fabric eliminates several integration layers that Power BI may require. OneLake consolidates storage, and Direct Lake mode resolves the historical trade-off between import and direct query performance. Time to first pipeline scores highest here, 5 out of 5, for organizations already running in Azure. For a SQL fluent team on the Microsoft stack, Fabric has the lowest onboarding friction of the 3 platforms. Where Fabric requires more careful management is its cost at scale. The capacity SKU model is predictable in structure. That is, you pay for a certain amount of capacity per time, but oftentimes the amount of capacity that you need, you don't buy enough. And so you need to upgrade to the next level of capacity, and instead, just buying 10% more. How the capacity SKUs work is each one is double. Each level higher is double the amount of capacity and double the cost than the previous layer. So if you only need 10 more % of compute, you have to buy a lot more than that. AI and ML readiness scores a 3 out of 5. Fabric's Gen AI integrations are solid and maturing quickly, but the full machine learning lifecycle, model training, feature engineering, experiment tracking is less mature than what Databricks currently offers. So strategic fit is this. Microsoft Fabric is the right choice for organizations where Power BI is the established business intelligence standard. The team has a strong T-SQL capability, and the speed to production is a priority where the team is already running on the Microsoft stack. It is not the optimal choice if machine learning workloads are the central product roadmap. Databricks excels in machine learning and advanced data engineering. For organizations where AI and ML are core to the product, not just an aspiration, but actively on the roadmap, Databricks is currently the most capable platform in this comparison. Governance and lineage score 5 out of 5. Unity Catalog is the most mature data catalog and governance solution in the category. AI ML readiness is also obviously a 5 out of 5. ML Flow is native, the feature store is production grade, and the platform has the deepest support for full machine learning life cycles. Trade-off here is operational complexity, where Databricks scores a 3 out of 5 on the operational burden. The platform offers a significant degree of configurability, which is an asset for organization with dedicated platform engineering capacity, but adds overhead for teams that are leaner and where data engineers are responsible for both building and maintaining the platform. Time to the first pipeline is also a 3 out of 5. The learning curve is steeper, and engineering maturity is a prerequisite for fast value realization. So the strategic fit here is that Databricks is the right choice for organizations where ML and AI workloads are central to the product roadmap. Snowflake's primary differentiation is operational simplicity and multi-tenant isolation. Operational burden scores 5 out of 5, the lowest management overhead of the 3 platforms. For organizations where data engineers carry broad responsibilities, or organizations where they have a lean data engineering team, this platform has simple maintenance, and this brings real organizational value. Also, multi-tenant isolation scores 5 out of 5. Snowflake's tenant per database architecture is the most established platform. Snowflake's tenant per database architecture is the most established pattern for SaaS organizations with strict data residency, HIPAA, or SOC 2 compliance requirements. For SQL Fluent teams, time to first pipeline is very fast. That's what we've seen in our client engagements. Cost management, however, requires active discipline. The credit-based consumption model is straightforward, but poorly optimized queries or unexpected workload spikes can produce cost overruns without appropriate monitoring in place. AI readiness has improved a lot, and the recent introduction of Cortex code makes usability of Snowflake AI ready and AI friendly. The strategic fit for Snowflake is this. Snowflake is the right choice where multi-tenant isolation is a hard compliance requirement. When the team is SQL first and when minimizing platform engineering overhead is a priority. It is the most operationally conservative choice in this comparison. Here's the framework that we use to guide platform decisions. There are 4 sequential questions. Work through them in order. So question 1, is Power BI your established business intelligence standard and replacing it is not on your roadmap? If yes, Fabric should be your primary consideration. The semantic layer integration with Power BI is a material advantage that is difficult to replicate in the other architectures. Question 2. Are machine learning and AI workloads, model training, feature engineering, vector search central to your product roadmap in the next 18 months? If yes, Databricks is the most capable platform for that workload profile. The others are closing the gap, but Databricks is currently the production grade choice for machine learning first organizations. Question 3. Do you have a hard multi-tenant isolation requirement? Yes, Snowflake's tenant per database architecture is the most established and lowest risk approach. This constraint tends to be binary. Either it applies and Snowflake's model is the appropriate answer, or it doesn't and the decision opens up. Question 4. Does your data engineering team have capacity dedicated to platform operations, or is platform management a shared responsibility across roles? If it is shared, look towards Snowflake or Fabric. Databricks configurability is an asset when there's a dedicated platform engineering capacity, but adds meaningful overhead when it isn't there. If you reach question 4 without a clear frontrunner, the binding constraint is operational. Snowflake is the appropriate default in that scenario. To summarize, Snowflake, Databricks, and Microsoft Fabric are all serious production-capable platform for 2026. The 1-point score differential in our matrix reflects how genuinely competitive. The 1-point score differential in our matrix reflects how competitive all these platforms really are. The platform that will serve your organization best is the one that aligns most closely with your compliance requirements, your team's engineering capability, and your AI machine learning roadmap. Work through the 4 questions, be honest about your constraints, and if you're working through a platform evaluation and want a second opinion, we can help. If you want to get your hands on to the Matrix PDF that I showed in this video, the link is below. If you found this useful, subscribe to the channel. We cover data engineering and AI strategy topics. I'm Igor, and I'll see you in the next video.